Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Fazidah Hussein and today I will be presenting my research with the title A Review of Aspects and Criteria of Daylight and Visual Comfort in International Green Building Rating Tools. I also love to introduce my fellow research team member who also contribute their effort and knowledge for this research, Dr. Azhan bin Abdul Aziz, Puan Mayami Yohanis, and Prof. Sabarina Sheikh Ahmad. We are all from Department of Architecture, Faculty of Architecture, Planning and Surveying with Universiti Teknologi Malaysia. The background study. Harvesting daylight in building always be an excellent choice, not only saving energy, but improve the body system through circadian stimulus. It is well known that daylight leads to energy saving while at the same time providing outdoor views to optimize human physical and psychological impact. When designing a building to maximize visual comfort and reduce the usage of energy, daylighting is given special attention. Green building inspection instruments, on the other hand, are used to access and classify buildings that comply with the outline of green requirements, which are also known as certification. Architects are likely to be motivated to design better lit daylight buildings by the rating tools guidelines. Instead of explaining the understanding and responses to environmental issues, competition between rating tools can send mixed signals that can confuse, particularly if building owners are unsure of which tool to use. Most of the existing green building rating tools, after all, are not homogeneous to each other and have different aspects and criteria for daylight and visual comfort. Although it is possible to incorporate the passive and active approach to an appropriate extent, the use of passive design technique is surprisingly limited. This is due to the lack of awareness, experience, and reference materials used to express the architectural and cultural values and environmental performance of buildings. Therefore, the realization of green buildings relies heavily on technical strategies such as active design. There are also often cases where aesthetic and cultural values are ignored because of the desire to focus on numerical analysis and technological applications, with increased technical reliance on green buildings. SF Mandler expressed her concern that concerning the topic of building environmental sustainability, there is an undue focus on construction technology in sustainable design and recognize the need for more systematic study of site planning and occupancy issues. On the other hand, Norbert Lechner pointed out that the stage of schematic design, the cost and environmental performance of a building is typically calculated. Furthermore, DK asserted that architects assign the responsibility for a building's energy use to energy contractors or engineers. He also found that advanced, high-performance structures for which an applicable passive design was overlooked at the schematic design stage usually resulted in higher costs even though they were green structures. Hawke and Bronstig suggested that unless sufficient passive strategies are used during the schematic design process, they can never be used in later phases, as passive strategies play an important role in structure-related decisions. In order to prospectively implement high-performance daylighting, passive heating, or passive cooling system, it is almost difficult to rectify the consequences of poor decision related to construction orientation, massing, and layout in later design phases. However, while many architecture practitioners are aware of the importance of passive design, its practical implementation is largely insufficient due to the lack of appropriate evidence and practice. The approaches used in the rating tools has been studied. The analysis done by Gyama make it easier to identify differences and similarities between them, both at the level of their general context and concerning the specific elements and parameters associated with the assessment process. Problem statement. However, competition between rating tools can send mixed signals that can be confusing, particularly if the owners of buildings are unsure which tool to use. The research gap. Most of the existing green building rating instruments, after all, are not homogeneous to each other and have different aspects and criteria for daylight and visual comfort. The objective, this research seeks to create holistic and thorough standards for achieving efficiency in daylight while enhancing visual comfort. The research questions: what criteria have been identified from rating tools that contribute to the daylight performance and visual comfort in office buildings? The research methodology. Differences and similarities between 7 following well-known rating tools will be addressed and contrasted. These differences and similarities between the following well-known tools will be explored, which are Energy and Environmental Design Leadership, LEAD from the USA, Environmental Assessment Phase of the Building Research Institution, BREEAM from the UK, Comprehensive Environmental Performance Assessment System for Building, CASB from Japan, SP2, the international tools, Greenmark from Singapore, and Green Star from the Green Building Council Australia, and Green Building Index GBI from Malaysia. These 7 rating tools were chosen. After all, they are internationally adopted and recognized as trustworthy because they are reflective of significant nations. Such labeling system can be considered to be the world's most popular and well-known and have been studied to demonstrate the basic daylight efficiency requirements. This will make it possible to understand which metrics have a greater effect on daylight performance to provide useful feedback for improving the current rating tools. Result and discussion. It can be concluded that there are 11 important criteria for daylight and visual comfort gained from the indoor environment quality and energy categories from the green building rating tools. The result of this study can be summarized in Table 1, which shows the aspects and criteria of daylight and visual comfort from 7 international green building rating tools, which are LEED, BREEAM, CASB, SP2, Greenmark, Green Star, and GBI. The criteria related to daylight performance and visual comfort were tabulated from the rating tools and involving 2 main categories, which are IEQ and energy. These are the 11 criteria extracted from the 7 green building rating tools. Number 1 is the daylight factor or autonomy. Number 2, openings by orientation. Number 3, daylight strategies. Number 4, lighting zoning. Number 5, glare control. Number 6, illuminance level. Number 7, exterior views. Number 8, lighting controllability. Number 9, high quality ballast. Number 10, external lighting. And the final one, number 11, materials and construction. Regarding Table 2, 7 rating tools are comparatively assessed and observed. The frequency from the comparison are presented, showing the total frequency of Aspect 1, the daylight performance criteria which representing the total A, and Aspect 2 of rating tools in total B. Aspect 1 of daylight performance indicate the 3 highest criteria in frequency are illuminance level, daylight factor, glare control, and high quality ballast. These criteria were found in almost all 7 rating tools presented. The criteria that were found with the least frequency are opening by orientation, daylight strategies, lighting zoning, and external lighting. Aspect 2, which representing the rating tools in total B, shows BREEAM has the highest value and almost complete the 11 criteria of daylight performance, followed by CASB and Green Star. Greenmark and SP2 representing the least of daylight performance and visual comfort criteria. The conclusion. In Figure 3, the context of quality of lighting and rating tools criteria of daylight and visual comfort are further explained in the diagram. To achieve a sustainable and yet healthy environment, daylight performance and visual comfort must be a complement to each other, and the best way to achieve them is by passive design. From the findings of aspect 1, it can be concluded that there are 11 important criteria of daylight and visual comfort from the two aspects of daylight design and visual comfort. These 11 criteria are the comprehensive and holistic criteria from the IEQ and the energy category of the green building rating tools. Criteria by ranking signify the following 11 criteria in the ranking system based on the frequency result in Table 2. The early indication of daylight performance strategy is likely to guide architects to design better daylight buildings. The result of aspect 2 regarding the rating tools show the green mark has the least criteria of the daylight performance, meanwhile green shows the highest criteria achieved in the rating tools. Based on the locality context, United Kingdom has limited daylight due to the temperate climate, and the criteria outlined in green is to fully maximize the ability of daylight, while Singapore, located in a tropical weather, has an abundance of natural daylight and less emphasis on rating through criteria of indoor environment quality, which is IEQ. A further study was recommended to establish the aspect and criteria of daylight and visual comfort from the local authority guidelines and the government bodies such as Public Work Department. The contribution. This early predictor of daylight effectiveness strategy is likely to lead architects to better daylight buildings. Future research. A further review is recommended to examine the aspect and criteria of daylight and visual comfort from the local authority guidelines and the statutory authority agency in order to provide more holistic recommendation for the attainment of daylight quality buildings. That's all from me. Thank you very much for your time. Hope you enjoy my research presentation. Assalamualaikum and thank you again.